Hello and welcome to the Ethereum Core Developer Meeting number 93. I'll be running it today. My name is Hudson, and getting on with the agenda, the first item is the Ethereum Classic chain split and 51% attacks, and if there's any client implications for Ethereum, and just to help us understand what happened more. Um, Wei, if you don't mind, going ahead and just kind of describing on a technical level what happened the first and second time that ETC got 51% attacked. And so we can kind of start talking about if there's anything we need to do from the Ethereum side to prevent something like that from happening here.
Um, yes, yeah. So I just want to focus on the technical aspect of this. So I mean, basically, it's the 51% attack was quite messy. It happened twice, and one interesting thing. I think the only really interesting technical aspect of this that also played a really important role in both of those two 51% attack is the maximum reorg cap. So the how many reorg you can go over the past blocks to go to the new block. So the interesting thing is for the first attack, it was detected because partially because there was a split between the Open Ethereum and gas client. And then the Ethereum Classic team firstly saw this was a bug in Open Ethereum, and they asked everyone to switch to gas. So later we figured out that this was not a bug. This was the maximum reorg cap of different values implemented in Ethereum and gas. So the interesting thing is for this time, there was an attacker chain and another chain which is manned by normal miner. I would call the legit chain. So for the legit chain, it's basically the one that is by the operated by the Open Ethereum client, and because of the Open Ethereum client has a really relatively low maximum reorg cap, around several hundreds, so all the Open Ethereum clients refuse to reorg into the attacker chain. But for all the gas nodes, the maximum reorg cap is quite big, so all the gas nodes immediately reorg to the attacker chain. And then later, because the attacker chain already has a higher total difficulty, so the ETC just proceeds to the attacker chain and then also create a minority split off of the Ethereum nodes. And for the second attack, so at this time, if the network maximum reorg cap would be lower than we would basically have defended the attacker. Like, it's not a really sophisticated attack, and the attack would basically have to be defended because the double spend will not work, and all the attacker manual words will be lost as well. So for this is the first time, and then the ETC team they asked everyone to switch away from Open Ethereum to gas. And then the second 51% attack happens, and this time they were not that lucky. There was no Open Ethereum miner, so basically everyone immediately reorg. And later they actually tried to whitelist the legit chain for everyone to man on the legit chain and ignore the attack chain. But because the reorg has already happened, so it's already too late to organize this kind of thing, and then that didn't happen as well. So it's kind of every time for both of the two times, the attacker successfully did this attack. So what I think is maybe worth discussing is whether we want to like coordinate for different clients on a value of the maximum reorg cap to like basically trying to make those simple, like for many 51% attack is not possible to defend, but for this simple type of 51% attack is indeed possible to just defend it by setting a maximum real cap and then basically just ignore the attack chain in this way. So from what I know, also in the after the second 51% attack on ETC, the ETC team, they also realized the issue and they are implementing they call the immutability threshold in their gas client. It's basically just a maximum real cap that is much lower than the current maximum default value in gas. So yeah, so
is the suggestion to have a maximum or not, or have a standard maximum or not have a maximum reorg cap?
I think those two attacks probably show that it would be better if we have like a default maximum reorg cap for that is probably standard across most clients. That may help, just my opinion.
So by the way, the default reorg limit in Geth is 3 epochs, so 90,000 blocks. And the reason why we chose that is because 3 epochs is about 2 weeks. And based on past, during the, I'm not even sure about it was the Shanghai attack. So no, it was a Byzantium switch when Geth and parity went out of sync. And essentially, the reason why we kind of chose 2 weeks is because we thought that, let's suppose the chain goes off in some really weird tangent for some reason, I don't know, attack, denial of service, whatever. And then it gets reorged back to the proper chain. And we kind of figured that 2 weeks should be plenty enough to sort out all this issue. And then if we set the maximum this immutability threshold to 2 weeks, then it means that after 2 weeks, if we didn't manage to solve the issue, then okay, you have to resync, you have to do a lot of weird things, but 2 weeks is a long enough time to allow the chain to sort itself out and everybody just get back automatically to whatever the network considers the canonical one. So that's why that is the reason why we have it at 90,000 blocks and not at, I don't know, half an hour or 1 hour, because this way you can automatically handle these scenarios.
And there's one other aspect that I think should be mentioned. So if clients start using a shorter reorg cap, it still doesn't change any client who does a fast sync and he just selects a peer with the highest difficulty. He will sync up to the wrong chain or whatever. And that's still an issue that needs to be solved, because otherwise you have this weird state where everyone who synced prior to a certain date, they wind up in one chain. But if they ever have to resync, it's gonna be very messy and painful.
I think this is mostly about attack scenario. So where like all the nodes will have to react immediately. Yes, there will be like if the reorg cap is lowered, then there will be a short period of time where likely all the miners will not be on the chain with the highest difficulty. But the thing is, after the attack is over, then the legit chain will still be quickly catching up on the total difficulty and overrun the the attacker chain in a really short period of time. So it's kind of a trade-off, but probably one argument I have is that by setting like maximum, setting this getting a standard maximum reorg cap, then we would be more likely to avoid disruption because the exchanges like miners, they are most likely already online during the attack time, and if their transaction getting reorged is a big issue. But if some new node sensing up the network during the attack time, then yeah, it's also an issue, but it's a much less severe issue because they can just resync their client after the attack is over or something.
Well, there's another side of this. So I think in Bitcoin Cash, they also had a similar issue because they were minority chain, and they one of their main clients, Bitcoin ABC, they have introduced the checkpointing. I think it was 10 blocks or something, which is very short. And the security analysis of that particular change was that although it does sort of reduces the risk of these deep reorgs, it could actually bring another, it could bring the possibility of another attack where essentially the attacker might get different nodes into having conflicting checkpoints. I mean, it's a bit more sophisticated attack, but essentially you end up different nodes checkpointing on different blocks and they will never be able to reconcile again. So you actually have to manually intervene and just reset the checkpoints and stuff like that. I don't know all the details, but I remember there were downsides as well as the upsides.
Yeah, yes, yeah. So so I just want to clarify that that 51% like is basically unfixable. But what I was trying to argue is just that like it will always need some intervention. But what I was trying to argue is it's just about how we can, like, if that happens, how we can like reduce the impact and make sure that the least amount of damage was dealt with. Yeah.
So the argument is that even if we expose ourselves to potential DDoS, it may or may not be better. So this is something to decide than having funds lost because of the 51% attack.
I'd also be curious to understand the dynamics of like the hash power here better, because I think a lot of the issues with Ethereum Classic potentially don't apply as much to Ethereum because there's just not kind of an available supply of GPUs you can rent as easily. So I'm not sure how that kind of changes the trade-off.
Well, the thing is that essentially ETC's security was broken down completely to zero. So somebody managed to unilaterally mine a more difficult chain than the entire rest of the network. So my problem is that we can discuss different ways to minimize the damage, but the actual damage is that you have an entity who can always mine whatever block and you can always force itself on the network. And then you can have this entity censor the blocks. You can have this entity, essentially you can have a single entity mine all the blocks in the network. The whole network can be taken over in this scenario. So the question is, how much does it make sense to protect against this? Yes, you can protect funds from maybe last 100 blocks of funds from being reorged, but this entity could just as well censor the network or do whatever they want. So what's the point at this point?
Yeah, I agreed. I feel like I'm not sure this is something that should be handled at the client level, I guess is what I'm saying. Because again, like if it's always going to be possible for somebody to just nice hash ETC for a couple $100,000, it seems like it's kind of a bigger concern than whatever the clients implement in terms of checkpoints.
So for example, another interesting attack. So the problem is that let's suppose we can 51% attack Ethereum mainnet. So what you can do is you just watch the DeFi exchanges for 5 blocks. You just collect all the transactions, and then you just create 5 reorg side blocks in which you maximize your DeFi gains by simply playing those transactions which you like, I mean the offers, and then you just counter offer them. And then essentially you can do a whole, you can completely maximize your profits based on these decentralized exchanges. And there you don't need to reorg 1,000 blocks. You don't need to break the network. Even reorging 3 blocks is enough. And that would be within the acceptable limit of any proof of work system.
So is there anyone who thinks that at a client level there needs to be changes made? Okay. So it doesn't sound like it. Anybody?
Or should we agree on a block? What, like the 6-3 epic block or something like that, and move forward with that?
Oh, the reorg cap thingy?
Yeah.
I don't know if it matters that much that they're the same across clients, does it?
I mean, I don't know if we have time for this, but in order to make these decisions, I think you have to also, Wei told us what actually happened, but you also have to think about and play in your mind what would happen if these 2 different clients have the same threshold. I mean, I don't think we should do it now, but if you just play it in your mind and see whether that outcome would be better than what happened, then yes, but maybe we shouldn't really change anything.
I agree. We definitely shouldn't agree to change something now. Like, I feel personally that thinking through the various scenarios and what would go wrong is we should do that exercise before we agree or disagree to change anything.
Thinking deeper, I think this would mostly be an issue for miners and exchanges, for them to coordinate a value that they think is acceptable. Yeah, but I agree, this is probably something, it's not something that we need to do on the client side.
Yeah, I'd also like to add that so some of the external parties that are suffering are exchanges. And Peter also mentioned the whole DeFi protocols and movements. And I just want to, I agree that on the platform level, on a strictly platform level, things work as they do. And if you need more robust guarantees about the order of things happening in your DeFi protocol, then you can't just rely on the platform, on the platform layer to don't reorg. You have to actually be stable enough and robust enough that it makes sense even in the case of potentially large reorgs. So I think the layer 2 needs to be more robust.
Yeah, but so the question is, what's the user experience? So the problem is that with the decentralized exchanges, even if you introduce some delays, you would expect that if you want to make a trade, and that trade happens within, let's say, a minute or 2 minutes or 3 minutes or whatever. Even that is, in my opinion, quite a lot of time. But just reorging, capping the platform's reorg limit to 12 blocks, I mean, that's obviously not possible. So let's suppose that we cap it to 200 blocks or 500 blocks, but that's already, we're talking about hours. So that would mean that if you want to make a trade on your decentralized exchange, you push the button and then you come back an hour later to see if your trade went through. So again, that's not really the best user experience. So anyway, honestly, I'm not even that familiar with all these decentralized exchanges. I just wanted to I wanted to highlight that once you accept that there are 51% attacks in the network, a lot of things start breaking, because a lot of things rely on the assumption that you cannot have deep reorgs. And deep, okay, every dApp is prepared to have a reorg depth of 1, 2, 3. But if you start accepting reorg depths of 200, then things will go funky.
Yeah, I mean, if we leave the reorg portion out of it, and I mean, one could instead have things like transactions which are only executable past a certain block hash. So you see a certain block hash, and you know the state root of that, and you say my transaction is only executable after this particular block. And I think doesn't like witnesses solve the same problem implicitly, since your transaction is only valid if these witnesses are correct, and the reorg would remove them.
Okay. So it sounds like we don't need to just to time box this. We don't need to make any decisions today, if any are even to be made, because there's a lot of variables involved.
Yeah, but I do think these things need to be talked about, because all of us are hoping that we will never see such a thing on Ethereum mainnet. But I don't think it's bad practice to talk about it, that if it happens, then what will be the outcome. So essentially what my point was that although I'm in favor of not changing anything for the moment, I'm also in favor of keeping discussions going about what can go wrong and what can we do about it.
Sounds good. Anybody else before we move on?
Is there a place we see the depth of reorgs that are happening? Because uncles are basically reorgs in its own way, or the depth of them happening, like where we see that information.
I don't know if there's any public dashboard of them, but so they're present in the Geth logs, and Geth also has a metric showing the length of the dropped blocks, drop chain, and the length of the added chain. So anyone who runs some infrastructure can get it charted on Grafana. There's a flaw on them right now. I think they're swapped. But yeah, the stats is there.
Yeah, and another way to essentially keep them for like historical analysis as well is that I'm pretty sure maybe the Geth already does that. So whenever you see the block, if it passes the certain criteria like proof of work is correct, blah blah blah, it has a parent and things like that, you essentially save this block wherever it becomes the canonical or not, and then later on you can go through the blocks that you saved and actually chart all the reorgs that happened, because you would have saved all these reorgs, you would have sort of received all that blocks, and then you can like go back in time and see, okay, what happened in that point of time. It just takes a bit of development to make this visualization.
So all in all, I would say that this is possibly, we could ask Etherscan to add this to their charts, because I think honestly this is more of their thing than our thing.
Okay, that's not a bad idea. Okay. Looks like we're going to move on to the next topic now. James, if you want to take this one, this is on the Yolo/Yolo v2 testnet, and any updates on Berlin State Test, if there's updates on either of those things, since it's been a while since we talked about it. James?
Yeah, this is just coming off of the break in July and wanting to get everybody synced at the status of YOLO and state tests and such. So if anyone has updates, I'd appreciate it.
Yeah, I don't have much updates, but I think it would make sense personally to have YOLO v2.
Cool.
Okay.
And did Peter and you start the Yolo v1 last time? Was that right?
Yes.
Okay.
Sorry, didn't find the button.
Oh, no problem. Okay.
And so with V1, we kind of messed it up a few times because the VM died in different ways. But if there's need, we can always reboot Yolo V2.
Do we want any more EIPs in Yolo V2 or just the same set?
Let's do the same set.
Okay, we can do the same set for now while we decide what other ones would go in at all. Because then we can do a V3 for the next ones, I'm guessing.
Sorry. So as in my mind, YOLO V1 is and will always be YOLO V1. There's like, in my mind, the YOLO V1 is a set of EAPs denominated by a commit hash to that EAP. And if we want, I mean, a YOLO V1 would be either a separate set of EAPs or if the EAPs themselves have been modified. I know Shamatar proposed some modifications to the BLS stuff. I don't know what happened with that. So if we just want to restart YOLO V1, I think we should still call it YOLO V1.
Yeah, and the reason I was asking is just because in a past Core Dev Skull, I remember, I think it was EIP 2046, which changed some gas costs that we discussed, including in like a future version of YOLO. So yeah, that was why. But I don't have a strong opinion on either side. Just want to make sure we're clear on what we're doing.
And we can pick this right back up after agenda item 3.A, which talks about 2046, and Alex Vlasov, I think that's your item, right?
Yeah, I mean, with all this kind of break and delay from development, like from further development of new features, it would be still, and with Berlin being obviously delayed, now there is a time frame where it would be possible to kind of work out all the details of, for example, 2046, or maybe some parts of 2666 with consistent pricing of precompiles with their current performance. So I was mainly interested in if client developers had some time to run the benchmarks and maybe post some numbers, so I can also analyze those.
And yeah, I know way back you produced some benchmark vectors, but you hadn't produced them for all the precompiles. Have you done so now?
Well, I did not place ModX just because ModX EAP is separate. But what I have produced is for largely hash functions and PN precompile, which like largely every precompile which is out there, which could have been potentially mispriced. And I've seen in the code base that Nethermind has integrated all these benchmarks. I just couldn't find the numbers in any like table form or maybe just a list somewhere. And as far as I understood from the Gitter chats that the Besu team, maybe they did run it, maybe they didn't, but they want to improve the performance, or maybe just don't want to disclose the numbers if they're very much off and a potential security threat. So I'm at least interested in kind of collecting the data. And even if the numbers in, for example, 2666 should be adjusted up a little bit to match the performance of all the clients, not just the gas and Open Ethereum, which I measured by myself. It's still necessary to know, for example, if there are some constant factors which are off, so which are kind of compensated with large static call price right now, but which can become potential issue if 2046 is accepted. So like 2666 as a larger proposal is a huge mix. It also proposes different error handling for precompiles, which is a completely separate question. We can discuss it now or maybe later if there is some time. But to push 2046 and at least some consistent pricing of precompiles, I at least need the data from client developers.
Yeah. I don't quite agree. What you need is a thumb up or thumb down from the client developers.
Well, I mean, there is a freedom in terms of cost parameters. Maybe I just need to tune them like 25% up, for example, to fit all the clients, not just all the clients except one. Then it's reasonable to make an adjustment in parameters than forcing every client developers, forcing every client to do some hard optimizations to fit into the performance window.
Yeah. So for gas, we are on board. We think 40 gas, at least I do, in 2046 is reasonable, but the actual precompiled repricing, we haven't done all the necessary benchmarks for that.
Oh yeah, I mean, I'm less worried about gas and Open Ethereum because I use them to come up with these numbers. But for other clients, I just don't have experience with them and not the languages they are written in. So I would need the numbers directly from developers.
So that would be if Besu has any kind of update on that.
Yeah, so I remember for 2046, we ran the benchmarks, and if it's been a couple of weeks, but if I recall, we were good with a price of 100, and I think 40 was slightly too low for us. I don't know about 2666. I don't think we ever ran the full benchmarks there.
And is there anyone here from Nethermind? Okay. Any other clients I'm missing here? Maybe Trinity? Yeah, I don't know if we were doing benchmarks for them in the first place. I think that covers every major client because TurboGeth is from Geth, so that'd be the same thing. Yeah. Okay. So Geth's on board. Open Ethereum. I guess Alex was running Open Ethereum's. You just said, right, Alex?
Yeah, I also benchmarked Open Ethereum in a way, like specifically for 2046. I benchmarked it in a Martin's proposed way, and the number for safe number for Open Ethereum was more like 26 or 25. So there is a margin there. So the proposed number of 40 was fine for it.
Is it worth including 2046 into Yolo V2 so that we can get more numbers run on them?
Not really, I think, because if we do it only 2046, then we, yeah, I mean, we could do that, but we will never roll that out on mainnet because we need to raise some of them. If we lower it by 660 gas.
Okay, so we'll put a pin on that one.
I mean, we could roll it out if we just want to try out the implementation. I don't really have an opinion.
It might be worth it to have more than just one thing before we do that. What were you saying, Alex?
Yeah, I mean, like the most like potentially dangerous part if there are some large kind of constant costs in various precompiles, which are for now covered by the static coal gas price and will not be covered by this. Those are partially identified and like not partially, they just identified in 2666. So if client developers would be willing to actually just run the benchmarks, and I would quickly check them if there are no such constant factors which are potentially dangerous, then on the next call, for example, we can kind of agree that on a number for 2046, and then just accept this and later on like do the separate EAP with repricing of the precompiles based on all clients' data. So I would kind of try to get the data first and then even try to kind of select a number for 2046 and try to implement it, or just vote for it.
Okay, that sounds
good
good.
to me.
So you want to do that by next time?
I mean, I would be willing to check the data and try to get something by the next call if I would be able to get the data from developers. But it's not up to me if there is data, if this data is available or not.
So
okay.
we would need benchmarks from Besu, Nethermind, and Trinity.
Not Trinity necessarily, because I don't think they were involved in the first benchmarks. But yeah, that's something we
I
could
think
ask.
Nethermind has all the data. Is just either I cannot find it or it wasn't posted somewhere, like in a plain clear text. It's integrated in the core case.
I remember that he ran the numbers and said something in all core devs, but I don't know where that went exactly.
Okay, well, I will try to search the history, but still then we need one more data point from Basin.
Yeah, we can definitely get that by the next call.
Okay, great. Is there anything else on that 3.A discussion point of yours, Alex, that you wanted to discuss before we move on?
It depends. If there are many items in the schedule, I can pass, but there was also a proposal to change error case gas pricing for precompiles and only for precompiles. But it would be a long discussion, I think, and quite opinionated.
Okay, we can come back to you if we have time at the end. Do you want to just do that?
Yeah, sure.
Okay. The next EIP we have is 3.B, EIP 2780, Reduce Intrinsic Transaction Gas. That is from Yuri, and I think you're on the call. If you want to give an intro to that one, and if you click on the agenda item, it brings you to a link to both Magicians and the EIP itself, if anyone wants to click on that and follow through while he's doing this. This also, I think Matt's involved, Matt Garnett. So if you are also on the call, yeah, you are. You can also comment on it if you want, but I'll start with Yuri.
Thanks. So yeah, I'll start with a shout out to Matt for actually creating EIP 2780. And I think I would like to start with outlining the motivation for this EIP and then kind of like, is it a good idea? Is it a bad idea? What should we consider and how should we make a decision? And so the motivation for, or basically the bottom line of this EIP is, can we reduce the cost of sending transactions from the current 21,000 gas into 7,000 gas? And the motivation to do that is that it became very, very costly just to make simple transactions, just to send ETH around became very, very expensive. I'm sure everybody here are aware of it. And there's a question, or let's say differently, the reason for that is that now transactions have to compete with very time sensitive and large amount transactions in DeFi. And it's a good thing, right? It's a good thing that the chain is actually being utilized by the most valuable transactions, and that's by design. But there's a question, can we enable more transaction on chain without bringing in negative externalities, or with just very, very small external that it's worth the cost? So if we were able to allow for 1,000 transactions per second on chain, and the only cost of that would be increasing the state size by 0.0001% and no DDoS like vector added or something, of course we'd like to do that. And if it was the other way around, of course we wouldn't want to do that. And so the question is, what are the downside of doing a step like reducing the intrinsic cost of sending a transaction? And so I want to go quickly over the different concerns and the issues with doing such a move, just in order to identify what is an issue and what is a non-issue, and what do we want to see, what do we want to test, what needs to be shown in or for all core devs to decide that this is something that should be done. And so the main items on the table of the concerns around doing something like that are, what are the implications on the state size, right? State size is already a problem. If we allow for something like that and it increases the rate at which the state increases, that's an issue. There was a concern brought up, I think, by John Adler, if doing something that allows for gas token to be allowed to manipulate the pricing even further. And Vitalik brought up the question of uncle rate. And so these are the main concerns around it. By the way, if anybody wants to hop in with a question or concern or clarification, feel free to just hop. Shoot.
Yeah, okay, a number of issues. So first of all, in the EAP, it says the creation of each account adds 20 bytes to the chain state. I don't know where that number comes from, but it's very, very wrong.
So that's actually a mistake. I think it was supposed to be 20 kilobytes.
That makes maybe more sense, yes. Secondly, so with 10 million gas, there's a max potentially of 476 transactions in a block. And with this, it will be thrice that, so 1,400 transactions in a block. And leaving state size growth aside, this means that blocks become huge. So other externalities is more load on the network side, more load on the disk, while syncing, more data to download. Today you have something like 500-600 million transactions from Genesis. It's maybe even more than that now. And each, I mean, it's if you consider that having been tripled, it's big, and yeah, I'm looking through this EAP. I think the security considerations or externalities are very much yeah, understated.
So generally I agree with you, and let's touch base, or let's touch upon this issue as well, about the attack vector. And when you say it becomes big, there is a question of, oh, just blocks becoming big, literally byte-wise, and there is on the other side, oh, if we triple the amount of transactions, how does that affect this side? Like, all these must be clarified and needs to be seen. But let's talk about specifically the point that you brought up. It's just one aspect to add there. There is a question of usage, and there is a question of attack, right? Whether increasing usage and, like, well, if usage increases due to this change, how does that affect the load, you know, the IO load and stuff like that? And there is a question, oh, could that be leveraged to create an attack? And my main argument regarding the attack is really saying, can this attack be launched today? Could that attack have been launched a year ago? And what would have been the cost of launching such an attack? So definitely should be further outlined in the EAP itself, in the EAP itself. But basically, because you're saying, well, what if somebody utilizes this new attack vector and just bombard the block with many small transactions? Can that, because now they're cheap, how much will that cost today with the high gas price and the utilization of the chain for DeFi operations? And how does that compare to how it used to be in the past? So I think I disagree with that with Peter on some discussion we had on Twitter. Should an attack vector be considered only in the context, is it possible? Or should it be considered in the cost of how costly it is to launch it? It's similar to the 51% attack from my perspective. Does that make sense to you?
I'm not sure.
Can I say something to this? So I definitely, I think this is, we cannot really, I mean, at this point, I think in a different time, we could probably discuss the peculiarities of the technicalities of this particular proposal. But what I would like to say is that the at the moment we have this crisis situation essentially, where we have a lot of externalities, as Martin suggested, onto the what I call basically core infrastructure of the network. So basically, I would look at the network as the core and as the boundary. So the boundary is where your transactions are coming from. This is where the DeFi websites are sitting and where the exchange is sitting, and a lot of these things. So the core is essentially the nodes which basically propagate transactions. They send around the blocks. And so the situation we have now is that the boundary is where the most value is created and captured. And the core is what services the boundaries. And at the moment, unfortunately, we are basically created the system where the boundary externalizes its cost into the core, and this is one of the reasons it's actually it could capture the value. So, and I would like to say that we do need to solve this problem, and that there are some proposals to solve it, to essentially try to reduce the externalities, try to push them out to the boundaries, so that the boundary participants of the network has to actually incur higher cost, and the core infrastructure has to incur lower cost. And I mean, it kind of logically, it might make sense that, you know, why the transactions are so expensive and so forth. But if we do this reductions of the gas costs and make it cheaper, then yeah, I would say that it probably will bring more users, but it will also make the crisis worse to the point where we are going to be crippled by these externalities. So, and I agree with you that in other situation, you know, we could discuss the technical merits, but my opinion is that we have to step back from it at the moment. And then we know already that the network is quite vulnerable to all sorts of DOS attacks. You know, we don't want to make it worse until we actually have a clear way of fixing it.
And something that I realized in the last couple of calls more clearly for me is that there's another additional dimension to consider. There's the is it possible, is it likely? But the third one, and I think is actually more important, and doesn't get talked about as much, is if it happens, what can we do about it? Like, what are the consequences? And with the state size and some of the other stuff, if something goes wrong, there isn't like an undo button for some of these things, which makes it more leaning on the side of security, in my opinion.
So I want to respond, and I'll try to respond to all these things. I'll start actually, James, with you, if you don't mind. I agree with that. The previous discussion, I wasn't participating, but I listened to that, really touched upon that idea, specifically state size. And this is why I want to point out what is an issue and what isn't an issue. So the idea is not to say, oh, we should do this and everything is fine, and let's just go ahead and do this, rather than identify what is an issue and what isn't an issue, and the things which we consider to be issues, how big of an issue are they, right? So Martin just did like a back of the envelope, like calculation. Oh, well, it seems to be big, 3 times big than it is right now. How does that affect in terms of load on the infrastructure? Or how does that affect the network? Alexei brought the point of, is it the boundary or is that the infrastructure? And as somebody who's working on the networking layer with the majority of the top 20 pools in Ethereum, like I completely agree with that. I do want to go over for a second here to talk about the state size and the gas token and the anchor rate, these things, in order to say, going back to your point, James, well, turns out that if we did this, if we reduce the cost of sending a transaction by 3x, it turns out that even if we go with a very extreme assumption that would mean 3 times more transactions, and it's very unlikely. But even in that case, yeah, the state size growth is a major issue and it needs resolve regardless of this. But it turns out that reducing the cost of sending a transaction that's going to, even if it triples, it's going to increase the growth by something like 1%, right? If we did this on January 1st, 2020, the state size in the past 8 months or so would have increased by 0.5%. So there's
Wait, so didn't you agree previously that the numbers were flawed in the EIP?
no, I don't have it, like I'll redo them. I don't want to do this on the fly. I think the calculation was done with 20 kilobytes and just what was written there was a mistake, but I don't want to give a conclusive answer to that on the fly when I don't have a second to look at that, if that's okay.
So
If that's fair enough.
sure. I was just saying that essentially to me, 20 kilobytes is equally, doesn't make any sense as 20 bytes. So essentially the leaf of a plain account that weighs give or take 70 bytes, plus you have the trie nodes, which are maybe a depth of 8 or 9. That's again, realistically, maybe 4 kilobytes or something. So the numbers should really be checked out.
Okay, definitely. And like something went wrong with there, and I would take a look. Maybe it was supposed to be 2 kilobytes. Again, I don't want to throw something from the top of my head. But going back for a second, I'm not arguing that, James, to your point, state size is an issue. The question is, if we change this, and we're talking about the usage for a second, putting the attack, does this open an attack vector that we don't want to open? Usage-wise, it doesn't seem to affect it much, even if the usage increased significantly. I go back for the motivation for a second. When the Ethereum chain becomes hard to use, I'm not even talking about, one of you guys said something about bringing in more users. This isn't about bringing in more users, rather than a lot of the people getting very, very frustrated that they can't build things on Ethereum, and stuff they could do in the past, they can no longer do. And that caused, like Ethereum has great momentum working for it, but it caused them to leak towards other chains, which is a shame.
I think the motivation isn't the key thing we need to be discussing. I think we understand the motivation. I think it's more what the risks are for this. I think that's where the focus should lie, because that's been mainly the questions being brought up. But we also need to time box this to a certain extent. And also, so my recommendation would be to shore up the numbers a little bit and maybe cross-reference them offline with a client dev, especially about some of the numbers based on what Peter just said. The different parts of the chain that gets bloated whenever stuff like this happens. Whenever you have a gas cost that's lowered like this. So if you want to give kind of a final summary of this, and then we can move on to other pieces of the topic. Sorry to time box, but we do need to move on.
No, that makes perfect sense, and I appreciate that, and I appreciate everybody's feedback. The idea was to get you guys to. Alex, do you want to say something?
Yeah, I mean, this EVE actually touches very a part for which there is no data available, and like from my perspective, purely technical, increasing the number of transactions in a block by a factor of 2 should increase the time which takes the miner to actually process and create the block, like twice the number of active actions in such a block. And on a previous call, maybe 2 calls ago, there was a number said by Alexei, which maybe was correct, or maybe it was just some random number in the chat, that for miner to be profitable, he can only spend something like 40 milliseconds to assemble the block. And this actually, trying to clarify this information would be potentially a separate value, because it could potentially affect not just this proposal, but other proposals too, which would later on try to increase the block sizes, or maybe introduce richer transactions, which require more pre-processing. And I don't know if core devs have any information of this kind, if it's not classified.
So I heard that 40 millisecond number. I think it's actually wrong. It's something like, looking at the logs from miners, it looks to be sometimes in the order of 200 millisecond if you don't consider the empty block they do immediately right away. but again, I want to wrap up everything. So you bring up a good point, but I don't want to waste further time. I just want just to wrap up. The idea is, can we, like, does this affect the time that miners require to process a block? Does this increase the time that just regular client, will that throw them off the chain? All these stuff are aspects. Does this open a DDoS attack vector? I argue that it isn't, but we need hard number for that. My goal here was to bring up and say which are issues and which are less of issues, but I'll take Hudson's proposal. I'll reach out to a few of the devs team here. I hope you thank you for being willing to respond in advance, and come back with probably on that EAP with more clarified numbers.
I'd say numbers, and then the things that you had listed off. Doing the research to show us that it's safe would get you the farthest, I would suggest.
So just one, what I want to do, like research, pardon me, like I have a PhD, like saying, like doing a simulation or something that is very, very not meaningful in compared to doing like a testnet and actually testing that. So my end goal here isn't to persuade people, oh, we should do that, rather than let's make it, it's a small technical change and let's actually test it and see if it can work, rather than make a theoretical argument that it should work.
Anything can work on an empty testnet.
Yeah, and it'd be hard to simulate. I mean, you can there's simulation software that, like, I've heard people have developed that can, simulate something like that, but like the type of stuff that like this group usually spins up doesn't have participation on a testnet widely.
Can I just say a couple of other things before we finish? But
Sure.
Because this is actually a pretty good example. This particular request is a good example of that. We can link to what we've been talking the last 3 calls. So I just can't pass it up. So essentially, what the other 2 things I wanted to say is that so we are. Sorry, I just forgot it. So the first thing, which I didn't forget, was that after the last call that we had, I sort of realized that we do need to make let it know the, let's say, Go Ethereum team and whatever the other teams will be running kind of more or less dominant clients. We need to give them opportunity to basically just say, no, we're not ready for this. Because otherwise, these core dev calls basically becomes a pressure group on a very small number of individuals, because we could come up and say, like, yeah, we want this, we want that, and so, but if they're not ready for it, if their client needs a major rework or something like this, they should just be able to say, no, we're not ready for this, please wait. Or if you don't want to wait, collaborate with the other client, help them to get around a bigger share, and then implement this change there, and then we will have to do that. And the second point is that, which I forgot again, sorry, is yeah, sorry, I forgot it.
That's okay. If you think of it in a second, you can bring it back up.
Yeah, sorry.
That's a good first point, though. Any feedback on that, anybody?
If we need to have...
I think...
What was that, Martin?
Yeah, I agree with Alexei, sorry.
If we need to have a bad guy, I'm happy to do it.
You always are.
Yeah.
So, let's see. Okay. Well, thanks, Uri, for wrapping that up. It sounds like we have some good next steps for you to continue on the process of exploring this EIP, and thanks for bringing it today.
Sure thing. Thanks to you guys for taking the time.
Okay. And yeah, Alexi, if you remember that, feel free to bring it up. I think you're one of the next ones anyway. Maybe. I kept this agenda item in, this next one, how transaction selection happens in a client at the moment. I forgot how far we got along in that on the last discussion, so I kept it in just in case anyone wanted to bring it up again. But I don't know if we actually need this because no one requested it.
So I think from last time, the discussion starter was mostly because on the spam on mainnet, and then we discussed various ways to get around the spam, making the sort order deterministic, and maybe just a single update that in Geth we did implement the this first in, first out sort order. So whoever submitted their transaction first will, so if multiple transactions have the same price, then they will be sorted in the mined block by arrival time. And this one we did implement it. We'll probably release it on Monday. And let's see if this helps the network or not. I think this was the discussion started last week.
Yes, that's right. Thanks for reminding. Other clients, are you all planning on doing any kind of transaction selection ordering, Besu or Open Ethereum, that you are like already planning on or might like think about?
We are not working on it and probably will not be working on it for the foreseeable future.
Okay.
Well, actually, I wanted to say about Open Ethereum because I know that they already have the same logic that the GEF just implemented. And the reason I know this is because back in 2017, when the parity used to sort, so the parity had the logic where if the transactions were the same gas price, it would sort them by transaction hash, which actually allowed people to mine, like to get the first entry for a certain block, sort of gas price. And I think it was very important, for example, with the status ICO, where they essentially capped the potential gas price, and so everybody was given like 50 gig away, and so you needed to be able to hash the transaction, which was has a low hash, to be able to get in. Anyway, so it really worked. And then I reported that issue and they fixed it. And when I looked at the fix, it was exactly what GEF just did now, is they sorted them by the arrival time. So I think unless this is changed, I think there's nothing there to do.
Okay. Besu, what about you?
It's not something we've looked at. I mean, it seems like it's a pretty small-ish change. So we could implement it, but I think we're waiting to see just how things go on the network. And once Geth is out, then obviously the majority of miners use that. So to see, what impact it has.
Okay. That sounds good.
Is the consensus to just order by arrival time?
That's it.
Oh, that seems to be the simplest option at the moment, with fewer downsides, I guess.
Sounds good.
If there,
we can definitely investigate different sortings. So honestly, it doesn't really matter as long as it's deterministic. But the other two proposals of so sorting by transaction hash still allows you to mine it, and sorting by account hash or account address still allows you to somehow try to. So essentially, it has this negative effect on the chain that people will start to mine accounts, and then it's you end up in these weird things that somebody actually let their GPU mine an account for a week, and then they have priority over all other transactions. So it's I didn't really like these approaches. That's why we went with the first in, first out, because that one, the worst that you can do is you can try to find where the miners are, and you can try to get a direct connection to them. Or actually, miners could sell you a direct connection. But at that point, they might as well sell you priority independent of when you submit your transaction. So,
Yep, makes sense to me.
and you said that was going to be released on Monday, possibly?
yep.
What would we look for if there was an effect? Where would we look for the effect?
I have absolutely no idea.
Well, probably you would. Well, the people who reported this initially, it was first talked about in the ETH Security Telegram group, and then a couple of them filed a ticket on Geth. I guess they're looking at the pools, the pending pools and stuff, and analyze the transactions. But nothing's going to happen overnight, because only when it no longer makes sense to do this spam will they stop, when it's more costly than it pays off. So it's probably going to take a couple of weeks at least before they realize that, hey, this doesn't really work anymore. We don't have to do it.
So the overall effect that we are looking for, which may or may not come, is that eventually if enough miners upgrade, then these plays where you submit a bunch of random transactions hoping that you will be the next one, these will essentially, you will only need to submit one single transaction and hope that you're the next one. It absolutely doesn't make any sense to submit more. And then people, or these people front running, they should fairly fast. So if they will realize that there's no point because they will just lose money on all the other transactions, then they should reduce the transactions. And that in turn should actually drive the gas prices down because you don't have gazillions of transactions, junk transactions, just racing to get included in a specific order. So the benefit, actually the effect that we're looking for is for the gas price to go down.
Okay. Thanks, Peter. Anybody else on this one before we move on? And if y'all update your agendas, I added a couple of things at the end that I completely forgot to put in. Just Regenesis and one thing I thought of about changing the software for the All Core Devs chat that I wanted to discuss with everybody. But first, let's go with Regenesis. Alexi, if you'd like to speak on it, if you could give a few sentence summary for those who haven't read the proposal, and then we can kind of discuss it for a few minutes.
Okay. So I've recently written what we call Regenesis plan, which is more detailed explanation how we could potentially go with it. And so to summarize what Regenesis is essentially we logically split the Ethereum state into two disjoint parts. What we call one part active state and the other part inactive state. We do not change the way that the state is Merkleized, so we keep the existing ways of computing the state root hash and things like that. So we simply introduce this logical distinction. And so then we introduce the notion of Regenesis events, and they would occur regularly at some either pre-scheduled times or maybe by manual decision. For example, 1 million blocks, which is roughly 6 months. And what happens at Regenesis event is that the active state is reset to just the state root hash, and everything becomes the inactive state. So then between these two Regenesis events, during, for example, the 6-month window, the rules of the games change for the network, and they change in like 4 different ways. So first of all, the transactions now will have to include an extra attribute, which is the witness, which is basically a string of bytes which encodes some Merkle multiproof. So I'm not going to go into details how exactly this is going to work, but I have thought about it quite a lot. And so what happens is when transaction executes, first we find any valid parts of this multiproofs, because actually a lot of them would be invalid, but there will be still some valid parts, and we essentially activate those parts that are presented in this witness, and we make them part of the active state, and then transaction runs. So then there's a block witness, which should be fairly small. So it's introduced simply for the miners to be able to prove their coin base, otherwise they cannot get reward. So for the block witness, it's attached to the block, and at minimum it should, if the coin base is not in active state already, but they should just include it into the block witness, and this block witness gets added to the active state before any transaction are executed. And so then what we do is we charge. I mean, in the hard fork version, that's the only thing we need to hard fork actually for the Regenesis, is that we have to include this witness, transaction witness, as a chargeable data. So at the moment we only charge for the data, but there will be also charge for the witness. And the nice thing about it compared to, let's say, stateless Ethereum design is that you don't have to figure out how to split this charge across multiple senders, because the transaction is only sent by one sender. And then the execution semantics of transactions change as well, in a way that if the transaction runs and it hits an inactive state, then basically reverts and the gas spent up to that point is consumed. But any effect on active state is preserved. And so then there's a proposal of change the chain ID so that after the Regenesis event, if anything was in flight, then it doesn't end up being failing, but people will have to resubmit transactions explicitly. And so the perceived benefit of this change is that if we regulate the Regenesis events properly, we might target, let's say, specific active state size, small enough, so for example that some modern machines can store it in RAM, and so that, or on devices with very low latency that you can get easily. And so that means that all the state accessing operations like sload, balance, xcode, hash, they just read from RAM, and it doesn't really matter. You don't have to keep adjusting their cost all the time. And then so basically then there is an implication for the transaction senders is that they need to acquire the snapshot of the state, but not the moving snapshot that we have in right now, but they just need to acquire the snapshot at the latest Regenesis event. And that should be enough for them to create a valid transaction. However, if they want to minimize the witness, they need a more recent snapshot. So this is where they kind of start optimize at their cost. And so this is actually what I'm, one of the kind of more philosophical reason for this Regenesis is that it pushes the cost of the operation from the core of the network to the boundaries, because basically the nodes which simply relay transactions, blocks, verify things, they start to expend less resources. But the nodes that inject transactions, and we assume these are the boundaries where people could capture value. And so these basically nodes will have to optimize a bit more. They need to make sure how to download the state. And if they want to have a fewer, like a smaller witnesses, they also need to get as fresh a state as they want. And so we kind of, the main difference from the status quo is that the failure to optimize stops becoming the systemic problem, because at the moment, if we have all the optimizations pretty much has to happen in the core of the network, and if we fail to do continuous optimizations, it introduces systemic risk and the network can fail. However, if we do Regenesis, then the optimizations will have to happen on the boundaries, and it doesn't introduce systemic risk because the boundaries are more diverse, they have more money around there, and if one of the operators falls behind, it doesn't matter. I mean, it will hurt, but not the entire network. So, and I'm not going to go into the details about how we could roll it out, because I think it's going to be very technical discussion. So I would invite everybody who want to discuss it to the ETH R&D Discord. There's a special Regenesis channel there, and there is also HTML file that I published on Twitter a couple of days ago, which details how could we possibly transition to this thing. I mean, that mentions the soft fork, hard fork, but I invite you to read that, and so we can get more technical discussions.
Okay, thank you, Alexei. Anyone have comments? Yeah, a lot of the discussion's happening in the ETH R&D Discord, so...
I have a question.
Sure.
So Alexei said that the transaction senders need only the state from the latest Regenesis event. Wouldn't they possibly need data from earlier Regenesis events? Generation?
No, so basically they need the data from at least the latest Regenesis event or more recent one.
Right.
And the reason, and so they will have, because basically, if they just simply produce the witness based on that snapshot, which was at the Regenesis, so the only risk that they're running is that their roots, so the elements of the witness which is close to the root will be invalid, but they will be recognized as such because they will be already, these elements will already be in active state. So it will be easy to find out which part of the witness is valid and which part is not valid. And so they don't need anything from prior to that, because essentially Regenesis is a kind of idempotent event. It does not depend on what happened in the previous Regenesis. It simply slashes the entire active state and we start over. So it doesn't matter what happened before. So if you look at it this way, it probably becomes clear that it doesn't have a historical memory or anything, this process.
And that's because the witness provides any information it would need. You'd have a witness along with every event.
No, because there's a convention that the witness it could be considered if it if it originates from any block header, from any kind of root hash from Regenesis till now. Any witness which is produced according to any of that state is considered to be okay. I mean, of course, the root part will be invalidated, but it doesn't matter. But if the witness is produced for the snapshot which is earlier than that, then we reject it. Maybe it will, some of the bits will still be valid, but it will be by chance, I think. So if you want to guarantee that it will definitely be valid, you should at least take the Regenesis snapshot.
So you can just point me to the Discord if this discussion is already happening there. I didn't know there was a channel for it, but I'm kind of curious about what is happening at this boundary and if there are any incentives to play some sort of game of chicken where you don't want to be the first one to submit a transaction that touches a ton of state because you want someone else to do that and include it in their witness so that you can then just assume that the state is already there. Have you thought about those kinds of things?
Yeah, I thought about this, and I don't really have I don't know if it's going to be a big problem for a couple of reasons. Maybe I'm wrong, but there's one thing is that if you essentially have, if you're like DeFi application or something and you run smart contracts, what you're probably going to do is that you're going to submit an empty transaction which simply reveals the beginning of the roots, like state storage roots for this particular contract, to make sure that everybody who interacts with this contract will need to submit smaller transactions. But if, for example, for the contracts which nobody ever cares about because they were like 3 years ago, obviously that's not going to happen. And then the second feature that there is, which fell out randomly almost, is that because there's a block witness which is used by miners to advertise their Coinbase, they also can use that to potentially repair some transactions. For example, if the miner sees that, okay, here's transaction, and it would fail because they didn't include the entire witness, but I'm going to just help them out to make sure it runs to the end. And so they would include that missing bit into the block witness, well, at their own cost, whatever, or risk cost. And then they will make sure that this transaction is going to succeed. So the miners will have the ability to repair the transactions. And I think these two things combined probably can alleviate this kind of risk, because the miners in the transition period, when we just roll these things out, and some people simply forget to, let's say, to put witnesses or something like this. So the miners could be benevolent and they might be able to repair some of them. But after a while, they just stop repairing and to simplify the infrastructure. So maybe there's such concern, but I don't know.
Okay, any final stuff from anybody else?
We'll talk about this in the next ETH1X stateless Ethereum meeting, which will likely be either this coming Tuesday or the Tuesday after that, or Wednesday, depending on Australia time.
Can you post that in the All Core Dev chat whenever the dates and time and the agenda is announced?
Yep.
Great. Okay, the last official item, besides reviewing previous decisions, is a lot of people, especially people who are normally active in All Core Devs chat, are now active in the ETH R&D Discord. I was thinking of talking to them about moving the All Core Dev chat from Gitter into All Core Dev so we can start having our own little section in there and make subtopics that we can then archive so that we don't have just one single chat channel, because I think we've outgrown that at this point. There's a lot of people in there. There's spam sometimes. There's not really good moderation. And it seems like a lot of people are already on Discord. So is there anyone who has thoughts, positive or negative, about moving the All Core Dev chat over slowly to Discord to sub groups?
I would say let's move today. Nonsense, do you?
That sounds good.
Yesterday.
My thought is if we could do that in a way. So one nice thing about Gitter is that it's publicly available, and the history of it is publicly available, which on Discord is kind of true, but not really. Like the history could disappear pretty easily if something happened.
Can that not happen on Discord too?
Yeah, that could happen on Discord. I actually could do a script to bulk delete if I wanted to.
Right, that's on Discord. It can happen on Gitter.
Sorry, I meant Gitter. I could do the same thing on Gitter.
You could?
Yeah.
But
Well,
just the admins of them could do that, right?
Yeah, exactly.
And I can link to there's a public link to chats on Gitter, but that doesn't exist in Discord.
Do you have something to say, Martin?
Well, no, yeah, I was going to say, so first of all, James, you have a pretty good point about you can send a public link to some random point on Gitter. And I don't think you can do that on Discord, not unless the recipient is also signed in. Yeah, I was going to say that I know that Gitter, it's very easy to just scrape everything. Jason, I have scraped all the rooms I'm in, and I can search locally for stuff. I don't know how easy that is with Discord.
Yeah, that's a good point.
I mean, like Discord, you could ban cryptocurrency, and then
yeah, well,
not exactly.
It goes down because they run out of money. If Gitter goes down, I have all the conversations I've ever been in scraped. It could probably be done on Discord as well. I haven't looked into it.
Yeah, I'm looking at the permission sets right now for like on a per channel basis, and you can make it so that people can't, for example, delete messages. I think people can always, I think everyone will always be able to delete their own messages. Someone correct me if I'm wrong. But they won't be able to delete others unless they're a mod. So that's kind of like how it is in Gitter. And then as far as Discord going down versus Gitter going down, who owns Gitter now? Because I thought Gitter could go down pretty easily too.
Doesn't GitLab own Gitter?
Yeah, last I heard it was GitLab, yes.
Yeah, so I think I wouldn't consider that more of that's a concern for any platform, but we'd at least have a chance to migrate off and archive and stuff, because there are bots that archive messages, and maybe a good solution is to have a bot that is accessible in the Discord that anyone can ping to get like a log file of all conversations for a channel, for instance. I know bots like that should be able to be created, and that's more of a long-term thing.
Yeah, my two concerns are a lot of these conversations are really important, and I would hate for them to just disappear because someone rage quits and deletes them historically. And that the Discord, although anyone can join it, as Discords get more and more people joining, they get more and more selective about who like joining and being able to join. So I have concerns about how public the discussion would be and how easy it is to share with people outside of the people in the channel.
Okay.
Those are all valid concerns, to be honest. If this is paramount, then Discord is not the best option, to be honest. If these concerns are paramount, and then I would seriously consider Matrix for this. Like, I know for a fact that Parity Technologies is on Matrix. I think Wei can tell us of this experience.
Yeah, it's Matrix is pretty great, decentralized and stuff. But yeah, talking about Discord, I was actually want to raise a concern. So also about the the archiving issue. So yes, I know there are actually bots and programs that you can use to archive the whole Discord conversation. But my concern is that might be against Discord's term and services. They might not allow like who archiving of a server's conversation because they somehow consider it to be private or something. So that's my concern. But for the Matrix, the user experience has improved significantly until recently, and they have a really great chat app called Element, previously called Droid. So yeah, so it's federated, decentralized that anyone can set up a server and communicate with any other server, stuff like that. Yeah.
The biggest thing in my opinion is the network effect and getting people to move on to something, and just looking through the list on the ETH-R&D Discord, it has every major client besides Nethermind, and Nethermind's actually in there via a bridge to Telegram. So we could ask them about moving over at least one of their people there as well.
I would be okay if the discussion's happening on Discord if it was mirrored somewhere that then is public and non erasable.
Yeah, I can see options for that. Let me think about that and explore options for either bots if it follows the terms of service, or a bridge that mirrors to a channel that's never deleted, or things like that. That's possible. And I also need to talk to the admins of the ETH-R&D Discord to see if this is possible in and of itself to move 1.0 chat there, because I know right now it's housing 2.0 chat and 1x research chat. So we don't need it. If they think we should do a whole new Discord for 1.0, then we'd have to explore that option. So I'll get all that together and come next time in 2 weeks with some possibilities without anything finalized yet. And with that,
Yeah.
I think we're out of time. Oh, what was that, Tim?
I was just going to say real quick, you mentioned the whole network effect thing. I think there'd be a lot of value of keeping a single channel if we migrate, and like over time we can maybe split it once the migration happens. But I think having just like all core devs on Discord or Matrix or whatever is probably like the best way to go, just so it's like you migrate to one channel from Gitter.
Mm-hmm. Okay. Yeah, that sounds good. Maybe start small is what you're saying. Okay. All right, sounds good. We'll see everybody on August 21st at 1400 UTC in 2 weeks. Thanks everyone for coming. Have a good rest of your day.
All right.
Thanks,
Thank you,
everyone.
everyone.
Thank you guys. Bye.
Bye.
You.